Hello, hello, hello. Mic check, mic check. Hello, hello, hello. Mic check, mic check. Okay, all right. So today is day three. Okay, okay. Yesterday I was not able to solve this question, so today I will start with this question. Okay, let's just refresh it. Okay, there's some questions left. Okay, on this time. Okay, let's just start with this question. Okay. So in this question, we have to make the uh, sum of both arrays equal, right? So I was thinking of using binary search, right? So what I can do is, uh, first of all, what I will do is, I will calculate minimum sum of array 1. Okay? Minimum sum of array 1 will be the size of the nums1 array, and the maximum sum possible of nums1 is just nums1 into 6. Okay? If all are 6. So the maximum for this array will be if all elements are 6, and minimum will be when all elements are 1. I can do like this also, right? Similarly, minimum sum 2 will be nums2 dot size, and maximum sum 2 will be nothing else than num2 sort type size multiplied by 6. Okay. Now what we have to do is we have to check for some intersection. Okay. Suppose the minimum is for this, let's say it is 20, and the maximum is, let's say, 100. And for this, the minimum is, let's say, 120, and maximum is 500. Then it is not possible to make the sum of arrays equal, right? Because there is no intersection between this minimum maximum and this minimum maximum. So I will do is I will calculate a range. Okay, from what can be the possible sum. Let's say uh, low will be maximum of the minimum sum of both, right? Minimum sum of both, minimum sum 2 should be minimum sum 2. Okay, and the high part will be nothing else than uh, maximum or minimum of maximum sum 2 sum 1, maximum of sum 2 or 1. Okay, now I have uh, what you say, low and high. So what I will do is now I will use binary search here while low is less than equal to high. Okay, and I will check what I will check. I will check whether this sum is possible or not, right? If it is possible, what we need to do, return the minimum number of operation, right? We need to find the minimum number of operation. Uh, see, it is 10 to the 5. Okay. Uh, then also it will be not be possible, right? I'm using binary search, but binary search will not be used. Hmm. I get a range to, low to high. That will be the common sum of the both subarrays. Okay. If low is greater than high, then it is not possible, right? Then I should return just minus one. That they will never be equal. What I need to do is I need to find the minimum number of options, right? So if let's say 20 is possible, then should I go right, higher, or lower? That I will not be able to determine using this approach. So 1, 2, 3, 4, 5, 6. Okay. Low is this, high is this. Okay. Hmm. You can make the sum of nums1, nums2. Okay. Let's say I get a sum 20. I can calculate the operation required to give the sum 20 from nums1 and nums2. Okay. If nums1 have greater sum, then I can decrease the sum. And if nums2 have lower sum, then I can increase the sum. I can calculate the operation. But should I loop? Not loop, right? Hmm. Using binary search. Suppose I get 20. Okay. Okay. Now it is possible. So should I go right or left? If I go right, I am looking for the higher sum. And if higher sum, then maybe nums1 will get less operation and nums2 will get higher operation. Hmm. I can loop in this side. Nums1, nums 10 to the 5. Let's say length is 10 to the 5, right? So, so maximum possible sum will be 6 into 10 to the 5. That is n. Okay. And minimum will be what? 1. Minimum will be 1. And to determine whether this sum is possible or not, it also takes n. So I don't think so that will be sufficient. I think it needed binary search, but uh, suppose I get, let's say, 1, 2, 3, 4, 5, 6, right? What is the current sum of this? 6, 4, 10, 5, 5, 10, 21. Sum is 21. Let's say I need a sum of uh, 12, right? So 6 will go till 1, 21 will be reduced to 16, I think. Because 16, 5 is, yes. Now comes 5. 5 will be reduced to how much? 1, 4, no, 3, 4, 5, 10, 11. Okay. Yes, so two operation. I'm saying that 12 is possible. Now, should I go right or left? Because in right direction there may be issue. What is the last code I submitted? So now in the last code, what I did was I calculated the difference of both subarrays right? And I try to reduce the difference to zero. First, I reduce the sum, and if it is not reducible, then I increase the sum here. If it is still not greater than zero, if difference is still equals not equals to zero, then it should be infinite. It is giving me wrong answers here. 5, 6, 4, 3, 1, 2. Hmm. So what should be the issue? Let's say I know if it's an equals to I want to what I need to it is the minimum number of operations required to make the sum of values constant. Okay, minimum number of operations, right? What is the minimum number of operations? Uh, uh, okay, so what should I think? Y is equals to max. If I can determine whether this is possible or not in login, then maybe it is fine. Then I can iterate from this low to high, right? Because low to if I iterate from low to high, then it will be I think linear case. Maximum can be n, right? High can be maximum n and low can be minimum 1. So it will be linear. So if let's say I got a sum of 20, how can I determine the minimum number of operation to give us sum 20? I'm still not using the property or something that it says less than 6. I should use something. I need to think something of this. 6. What does 6 mean? 6, 6. So the value can be 1 till 6, right? Hmm. I'm using here. I need to calculate the minimum number of operation, right? Minimum number of operation. Mm, how to calculate? Let's say I sorted this array 1, 2, 3, 4, 5, 6. Okay. Let's say I want to decrease the sum. So this is 6, 5, 11, 15, 18, 20, and 21. Okay, let's say uh, my current array sum is 21, and I want to what decrease the sum, right? I want to decrease the sum to 12. First of all, what I will do is I will calculate the difference. Difference is how much? 11, no, 11, no, 9, 10. Yeah. Difference is 9. Okay. Since I got the difference 9, what I will do is I will go till here. I will take the upper bound of 9. I will take the lower bound of 9. Okay, 9 comes here. So I know two elements need to be changed. Okay, is this correct? Mm, yes, I think it's so correct. Yes or no? Yes, I think it is correct. Suppose because this can be minimum 1, right? Yes, yes, minimum 1. So this can give me sum of 2, 3, 4, 5, 5, 5, 12. So I need to change it, right? or else I can do is one less. Okay, so 5, 4, 3, 2, 1, and 0. So now let's calculate this 9. Okay, so I need to reduce this sum, right? So what I will do? Okay, I got the intuition. So by using this, I can calculate the number of operations in login time. Okay. What about increasing sum? Okay. And from here, what I will do is 5. I can increase 5, 0, 0, 1, 0, 0, 1, 2, 3, 4. Okay. So for increasing sum, I will start from here, right? Yes. So for increasing sum, what I will do is, what should I do? For increasing the sum, I can suppose, let's say, currently nums2 is 1, 1, 2, 2, 2. What is the sum? 2, 2, 4, 6, 10, 6, 7, 8, 9, 10. The current sum is 10. Let's say I want to increase to 15, right? 15. So 15, I want to increase 15. So how many elements I need to change? Let's say 6 minus 1 is 5. Okay. And okay. Hmm. Okay. So what I will do is, wait for a minute. Okay. So what I was doing. Okay. So first of all, what I will do is I will sort the both arrays. Sort nums1 dot size, nums2 dot size. Okay. First of all, I will sort the both arrays. Sort nums2 dot size, nums2 dot size. Okay. Okay. If but okay, also I need to calculate the sum. It says sum1 0 and sum2 is 0. So what I will do is for auto ampersand element in nums1, sum1 plus equals to this element. Similarly for auto ampersand element in nums2, sum2 plus equals to this element, right? Okay. And if sum1 is less sum2, okay, so what I'm doing is I want so that nums1 will have the greater sum, right? So I will swap nums1 with nums2 and I will swap the sum also. Sum1 comma sum2. Okay. Now nums1 have the greater sum. Okay, so nums1 should be always reduced, right? So I will create a vector temporary uh, prefix 1. Okay, and let's say n, it should be of length as of nums1 dot size, initially it will be 0. Pref and it will be nums1 dot size will be nums2 dot size, right? Let's say so it will be n. Okay, so prefix 1 of n minus 1 will be what? Prefix n minus 1 will be nothing less than what I'm saying. Sorry, the value it currently has nums1 of n minus 1 minus 1, right? Okay. Now for integer I equals to n minus 2 till I is greater than equals to 0, I minus minus prefix 1 of n minus 1 prefix 1 of sorry, I will be equals to prefix of n minus I, sorry, I minus 1, and this should be 1, prefix 1 of I minus 1 plus nums of I minus 1, right? Okay, so this part is done. This part is done. Now, yes, so tell me. Okay, and let's start with the array which has lower sum. Vector, integer, prefix 2. It should be of length m. So prefix 2 of 0 will be what? 1, sorry, 6 minus nums 2 of 0, and for integer I equals to 1, say I less than m, I plus plus prefix 2 of I will be prefix 2 of I minus 1 plus 6 minus nums 2 of this I, right? Now prefix part is done. So what I will do is I will reverse this because this will be in reverse, right? So I will reverse this prefix 1 so that it is easy. Okay, now is done. Now what I will do is I will iterate over all operation. As the operation is int max. Now for integer, let's say while low is less than equals to high. Okay. Now I want to calculate the sum low. Okay. I want to calculate the sum low. So hmm. So if operations, so if let's say wait a second. In this always degrees operation will be there. And this always degrees operation. Is it right? I don't have. Yes, in this also always degrees operation. Increase the horizon. In this minimum zone. नहीं इसके भी तो डिग्री हो सकता है इसमें भी डिग्री हो सकता है God is you. Okay. What I'm doing? Swap. Okay, okay. Prefix one. Prefix one is this. Okay. So this one is for what? Decreasing, right? And this one is for increasing for the second end. So let's say what I will do is I will also create another vector. Decrease, increase. Let's say inc and 0. I want to increase, so I will start from here, right? So what I will do is for integer equals to 0 less than an I plus plus. So inc of I will be nothing less than 6 minus nums1 of I. Okay, and if I is greater than 0, inc of I will be plus equals to inc of I minus 1. Okay, similarly for this, let's create a decrease vector. I don't know what I'm doing, but let's see. Comma 0. I want to decrease it, so I will start from here. So for integer I equals to n minus 1, not n minus 1. So I is greater than or equals to 0, I minus 1. Decrease of I will be what? Decrease of I will be 1 less than that. Huh? So nums2 of I minus 1. Okay, and if I is less than n minus 1, then decrease of I plus equals to decrease of I plus 1. Okay, and I will also reverse this. Decrease, okay, this not end. Okay, now it is fine. Now let's see. Okay, if someone is greater than low, else. Okay, if someone is greater, if, if someone is greater, that means I need to decrease the sum, right? So what I will do is, where is someone? This, so prefix one. So what I will calculate is, I will calculate the difference. Def one will be absolute of someone minus low. Okay, difference one again. If someone is greater than low, so I need to decrease the sum. 5, 4, 9, 12. So I need to find a lower one. Auto iterator will be what is the prefix one, right? Prefix one dot lower, oh, sorry, lower bound prefix one dot begin, prefix dot end, so prefix one dot end, and the value I'm looking for is what? This different, right? So operation will be operations plus equals to, let's say it is like this, 549. So this minus, so operation will be IT minus prefix one dot begin, right? This will be if someone is less than low. If someone is less than low, that means we need to decrease, right? So that means we need to decrease. So 4, 8. So again, what I will do? What is the decrease? Increase. Okay, I need to increase the sum, right? So I will increase from here. INC. Auto iterator will be again lower bound of INC dot begin, comma INC dot end, and the diff1 operations plus equals to IT minus INC dot begin. Okay, as if someone is less than low, right? Same kahani with diff2 will be absolute of this low minus sum2. Okay, so if sum2 is greater than low, but sum2 is greater than low, so we need to decrease the sum, right? So for here I use dic. Okay, so instead of this DEC, 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 and this is for this it is prefix to prefix to this is diff2 and this is prefix to, right? Not bilingual. Wait a second. Okay, and what I will do is I will increase the low. These are the operations. So I need to find the minimum. So minimum of so OP will be minimum of OP itself and the operations. And then I will return OP is OP is impacts as let's see. Oh my god, what is this? What the hell is this? Oh sorry. Let's see. Addition of unsigned offset. What do you mean by that? If IT is not equals to prefix prefix one dot end. Okay. See. Prefix to okay. Where it is giving problem. This part of what right. Okay, somewhere here. So what I am doing, okay, someone swap हो गया n will be nums1 dot size, m will be nums2 dot size, prefix 1 n minus 0, so n minus 1 nums of n minus 1, okay, later prefix of I will be, okay, not I minus 1, right, prefix of I plus 1, okay, let's see, output is 0, How can output be 0? See out. No. What are the possible lows value? Okay, 6, 7, these are the possible, right? Hmm. Okay, we don't need to do this. Let's move on to the next question. Time is over. Okay. Okay. Uh, let's wait for a minute. Okay, Max. Let's move on to the next question. Let's start the timer. Okay. Maximum number of consecutive values you can make. Okay. You are given an integer array coins of length m, which represent n coins that you own. Okay. So I own coins 1, 3. Okay. The value of the ith coin is coins of I. Okay. You can make some value x if you can choose some of your n coins such that their value sum up to x. Okay, fine. Return the maximum number of consecutive integer values that you can make with your coin starting from and including 0. Note that you have multiple coins of the same value. Okay, so we can take any number, right? So can I make 0? Yes, I can make 0. Can I make 1? Yes, I can make 1. Can I make, let's see from here. Can I make 0? Yes, 0 is always possible, right? Can I make 1? 1 is possible, yes. Can I make 2? Yes. Can I make 3? Yes. Can I make 4? Yes. Can I make 5? Yes. Can I make 6? Yes. 7? Yes. 8. Okay. So I understood the problem and they want to find the maximum number of consecutive integer values, right? Let's see the test case. Coins is length 10 to the power 4. Values are also 10 to the power 4. Okay. Hmm. Okay, alright, alright. So if I think, what about linear? So what I will do is, let's say I want to check whether 1 is possible or not. 1 is possible. 2, I can 2 make with 1. Okay. Hmm. How can I do this? So what I want to do is I want to calculate the maximum number of consecutive integer value. So maybe what I can do is I can use binary search here because maximum, let's say I want to check whether 14 is possible or not. If 14 is not possible, then I know the solution will be on the left side. Let's say 7 is possible. Then I know the solution will be on the right side. Let's say 10. Okay, 10 it is possible. So I will go on right. And 12 it says it is not possible. So I go on left. 11 it says not possible. So minimum is 11. So I know. Okay. So if I use binary search, then for a particular value, let's say 12, I need to calculate whether it is possible to generate a sum of 12 or not. Okay, that is the main issue here. Mhm. Now, how can I do this? I want to generate a sum 12 from this. Let's say 7, right? 7. You cannot make 8 conservative starting from 0. Okay, let's say 8. It is not possible from here. Okay. Hmm. 10, 14, 4, 5, 6, 7, 8, 9, okay, 20. Okay. Now from here you can see that I cannot make sum of 2. The question asks whether I think can I able to do it in linear time using the coins. Okay. How can I do this? We give the sum. Yes. How can I able to tell whether this sum is possible from this or not? What I can do is mm, see some maybe I can go linear. I will say okay 1 is possible. Yes, 2 is possible. 2 can be made from 1 plus 1 or 0 plus 2 if 0 is possible, right? Is 2 there? No. Is 1 there? Yes, 1 is all present. And they are saying that note you have multiple coins of the same value. Okay, I can have multiple coins. Okay, so every I cannot repeat it, right? Okay, okay. Okay. If I am able to determine whether the sum is possible or not in linear time, then I think it is will be easy. And then I can use just find search. How to determine whether sum is possible? Okay, let's drag it. We have okay. Oh my god. Okay, let's say I have some. Let's say 1 1 6. Okay, I can generate 1. Okay, I can generate 2. Okay, but I cannot generate 3. Why? For 3, mm, coins of I is also very greater, right? The sum of all coins I will be 10 to the power 4 plus 4. 10 to the power 4, 10 to the power 4 is to 8. Okay, it is, I mean, fine. Okay. Mm. 1 1 1 4. Mm. I think in linear time, sorry, n square time, I will be able to do that because let's say 0 is always possible, right? So for 1, I will iterate on the below side. So I will say, okay, uh, 1, okay, so I will say 0, 1 minus 0 is 1. So I need to find a coin which has a value 1. right? Is 1 present? Yes. Okay, now 2. So for 2, okay, okay. How to do it? Let's say 1114, right? Hmm. You can make the following values, okay? Um, I can take 0, 1. Yeah. Either I can generate all, uh, what do you say, all subsequence of the array and then determine whether it is possible or not. But that also will not be not right. I just need to find whether the sum is possible. Let's say I have a sum 2, right? Okay, sum 2, good. Hmm. What will I do? 1114. What is the time complexity if I generate all subsequence? If we were to talk about it, right? What about I memorize it? But I need to find the sum. Okay. So let's say 1114. 5. 1 layer, 1 layer, 4 layers. So 4, 5, 6. This is not giving solution. Hmm. I want to generate a sum. How can I do it? You can make the following value 0 and 1. Okay. Two consecutive integer values starting from 0. Okay. 1114. Okay. How to do it? How to do it? How to do it? Let's see something out of the box. What I want to do is I want to use the coins to generate a sum, right? And I want to make consecutive. So I believe consecutive will be fine. Hmm. Uh, hmm. Okay, I know the value of my answer. I know the values in range and I know whether it will work or not. How can I generate a sum? 1114. Let's say I have a sum, let's say I have a sum 4, 5, 6. Let's say 4, 5, 6, okay, 2, 3. Okay, let's say I want to sum of 3 from 114. Then how can I just need to check whether it is possible. First of all, I need to check whether it is in the range. Okay, it will always be in the range. What I will do is, I will take this one, minimum. I'll take this. Oh, okay. Now I need two. Two possible. Then I take this one. Is one there? No. Okay. Hmm. Okay. One is not there. Then what? Oh no. Will it always be able to? Okay. So I need a sum of three. Instead of checking whether it is possible or not, what I will do is, mm, I I just need to find whether it is possible or not. Right. I'll check whether it is possible. It is not possible. When it will not be possible. When it will not be possible. When. When one thing it is not present there. Yes. Another thing will be it is not present there. Another thing will be when there is what data scale. When there is something different. Okay. What? Hmm. If it is not present in the array and the sum of its all the values on its left, sorry, less than that are not greater than. Sorry. Yes, yes or no? I think so, yes. But let's say 2 to 4. Let's say I want to sum of 3. Okay, now 3 is not present. Okay, 3 is not present. But the values on its left side are 4. 4. I need sum of 3. 1, 2, 3, 4, 5, 6, 7, 8. Mhm. Okay, let's say I take consecutive. Then what? I need a sum of 1. Okay, fine. I need a sum of 3. Now, sum 3 can be made using 2. I will check whether for making 2 what I needed. Hmm. You can make 8 consecutive. These are values starting from 0. Hmm. That is good. Right.